Welcome back to this second coding session to build a memory game. Last time we finished implementing the initial logic to create the board with the numbers in random order. Well, one of the things that I didn't do is to go through the function getRandomArray. I just copied and pasted it from Chat GPT. But this is actually a very interesting function. I think it's worth exploring it just to see how it works. So this function, the only thing it does is it gives us an array of numbers from 1 through 9, which are in random order. And as you can see, it first defines an array of numbers from 1 through 9, which are in regular order, and then it uses the Fisher-Yates shuffle algorithm. And this algorithm shifts numbers in place, and then it returns the array. So this part is really interesting. This is where the shuffling happens. So let's actually play a little bit with this to get a better understanding of what's going on. I'm going to go to mycompiler.io, and I'm going to use the Node.js compiler. I'm just going to I'm just going to copy this code. And then paste it here. So I'm going to get rid of these tabs. And then let's start by looking at the value of I. And as you can see, I is just a custom, it's just a list of numbers from A to 1. And that's going to be the same every time you run the array. So same list of numbers, same list of numbers. Now let's move this over here, and let's also log the value of J. And now you see 8 is random numbers. And if we run that again, we get a different combination of numbers on the second column. And no matter how many times we run it, we're going to be getting a different list of numbers on the second column. So J is basically just a random number from 0 to 8. And the way this Fisher-Yates algorithm works is by taking these two indexes in the array and swapping their values. So first, we can actually see that if we log the array. Now, in the first pass, well, this is 8 and 8, so nothing is swapped in this first pass. On the second one, we have 7 and 3. So the number in the index 7 of the array gets swapped with the number of the index 3 on the array. And you can see that 0, 1, 2, 3. We have an 8. And in the 8th position, we're going to have a 4. 0, 1, 2, 3, 4, 5, 6, 7. We have a 4. So these two numbers, these two values got swapped in this pass. And then you have 6 and 6. And again, nothing changes because you're basically assigning the same value on the same position. But then on this one, we have 5 and 1. 0, 1, 2, 3, 4, 5. You have a 2 that used to be in the second position of the array. And in the second position, you have a 6 that used to be here. So these two values got swapped. And the same thing happens for each round of the loop. And the way that works is by assigning on array I the value of array j, and on array j the value of array I. And that's how these numbers are swapped their positions, and you end up with a shuffled array. Let's get rid of this line and also this one, and let's just log the array. Also that log array. Now we have 937862145, and if I run the code again, we get a different combination of numbers: 847512369. And if I do it again, we get yet another combination of numbers. So that's how the Fisher-Yates shuffle algorithm works, and it's very nice. It's a very nice and quick way to shuffle the numbers and get them in a random order in this game. So let's continue with the game, and the next thing I want to do is to, after a few seconds have passed, I want to hide these numbers and instead just show asterisks. So after this, I can do a set timeout, and I'm going to call a function that's like cards, and then I'm going to call this after 5 seconds. Then let's write the hide cars function. And then, as always, I'm just going to alert just to make sure that this function is working as expected. I think it's not working as expected. Let's try that again. And we have an error. Okay, that's a problem. We need to move the function's declaration above the line where we are accessing the function. And there you go, we get B. And what we can do now is to erase the content of each cell. And there you go. Oh, this is actually, I made a mistake. This part should be the body of the function. And now you can see after 5 seconds, the numbers disappear and you get asterisks. And the asterisks are not actually content. So rather than setting the inner HTML of the cells to the asterisk, we are just setting inner HTML to an empty string. And then because of CSS, we've declared that any table cell that is empty is going to get an after pseudo element with the content set to asterisk. And that is how this asterisk ends up here, even though we are setting inner HTML to an empty string. So let's rerun it. Get the numbers, and then after 5 seconds, you get asterisks. I think 5 seconds is enough to memorize the numbers, but I don't know, maybe not. So let's actually try to determine if that's enough. So I'm going to console that log numbers. 746153829. 746153829. 746153829. 746153829. 746153829. Yeah. 5 seconds is enough for you to memorize the numbers and still keep it interesting. We could do 10 seconds, 15 seconds, but then that kind of lowers the challenge. So I think that's going to be it for this session. It's not much, but the primary reason, or I guess the primary objective of this session was to take a look at the getRandomArray function and just to explain how it works. And of course, we did get to advance on our game by setting a timer that hides the numbers. On the next session, we're going to be making it so that you can actually click on these cards and pick from a list of numbers the number that you think is hidden behind the asterisk. So, see you next time.